what is a GAN? Let's say you place a keyboard in front of a monkey. And how long do you think the monkey will take to type a letter A? Probably within several minutes. How about a three-letter word? Probably within hours. If you extend that, what about a valid sentence? It could be any simple sentence. Probably within several days. Then the infinite monkey theorem states that given an infinite length of time, a chimpanzee punching at random on a keyboard would almost surely type out all of Shakespeare's plays. So we know what generator is. Now, Ian Goodfellow in 2014, while they were sitting in a bar, thought of this idea. What if we connect a discriminator to the monkey's typings? And we backprop the error back to the monkey. And we train both the discriminator and the monkey, in this case generator, simultaneously. And that is GAN. So the generator generates fake samples from random noise and let a discriminator classify it along with real samples. Both the generator and discriminator are simultaneously trained using backprop updates based on the classification error by the discriminator. Fake sample nudges the discriminator to say 0 more on synthetic inputs and say 1 more on on real inputs. Backprop update on generator makes it more likely to produce real synthetic inputs. But the Facebook guys found that GANs are difficult to train using CNN, as it requires finding a Nash equilibrium of a non-convex game with continuous high-dimensional parameters. What a mouthful. Okay, so they played with it and found that CNNs can be modified. They found that pooling layers are a bad idea for GANs, that you need to remove fully connected layers. Instead of classifying individual samples as real or fake, classify an entire batch as real or fake. Use label smoothing, that is, instead of 0 for fake and 1 for real, have a 0.0 to 0.3 as for fake and 0.7 to 1.0 for real. For downsampling, use average pooling, convolutional layer plus stride. For upsampling, use pixel shuffle, convolutional transpose layer plus stride. And in the discriminator, use batch normalization, all layers except the input layer. Use leaky ReLU in all layers as your nonlinear transform. Use the stochastic gradient descent optimizer. In the generator, use batch normalization in all layers except the output layer. Use hyperbolic tangent in the last layer and leaky ReLU in other layers as a nonlinear transform. Use the Adam optimizer. That's what they found. And guess what? Here is the magic. When CNN was modified, they got the, you could do a cool thing like using vector arithmetic, like you had a image with sunglasses, you do minus, you get a person without sunglasses, and then you add a woman, and you have a woman with sunglasses. Let's see how DC GAN might work by building a cat generator. Here is the generator code. It's Python, so simply You generate some random numbers and then you get some image like this. Now, the discriminator will definitely say, this is no freaking cat, and pass back the error to the generator's cost function. The question is, what is the intuition behind how the generator should be organized so that it can do a backprop to the generator